Hi dear students, welcome you all to another session of Brainiacs Doubt Clearance. So today we will be dealing with some of the important questions from the topic aromaticity. So here uh, the main agenda of this discussion is I will give you some of the important questions and you need to tell me whether the given compounds are aromatic or not. Okay, so I can say comment if the below organic compounds OZ, okay, organic compounds are aromatic or not. Okay, coming to the first question number 1. Okay, so I have drawn the question. Yeah, so I completed the question. Now you could comment whether the given compound is aromatic or not. So I have taught you already the detailed theory. If any of the students want to listen to that, please contact Brainiacs Classes. You will get the detailed theory. Now I will just explain you some important shortcuts. With that you will be able to say whether the given compound is aromatic or not. So I told you there are four main things or four main criteria you need to consider. The first criteria is what? Actually you need to check the given compound is cyclic or not. Correct? What is the next criteria? You need to check whether the given compound is planar or not. Okay, to check the planarity, what you need to do? Check all the hybridization of the carbon atom which forms the ring structure. Now in this question, you know, this is a carbon atom and this is connected to another carbon atom and this is connected to another carbon atom. So check whether all these three carbon atoms are what? Actually sp2 hybridized. Why we are checking whether it is sp2 hybridized or not? Because sp2 hybridized means its shape is planar. Correct? So this is the shortcut to check whether the given organic compound is planar or not. Now what is the third criteria? You should check for cyclic resonance. What is it? Cyclic resonance. It is not the normal resonance. It is cyclic resonance. So what is cyclic resonance? Whenever the conjugation happens in a ring completely, we say it is cyclic resonance. Correct? I will give you one example so that you will understand. Now I am taking the case of benzene. Correct? So in the case of benzene, if you see here, you could understand that there is conjugation. There is double bond, then single bond, then double bond, then single bond, then double bond, then single bond. That is, conjugation is happening throughout the ring in a periodic fashion. This we call it as cyclic resonance. What is it? Cyclic resonance. Correct? Now suppose the given question, okay, suppose the given question is this one. I will give you this question, then it will be very easy to distinguish actually. Suppose it is given like this, only like this. Now I know that double bond, double bond, then single bond, single bond, single bond. So that means there is resonance from this portion to this portion. Correct? Double bond, single bond, double bond. That's a conjugation. But throughout the ring, there is no resonance. Why? Because double bond, double bond, then single bond. Then here double bond should come, or some lone pair should come, or some positive charge. But it is not there. That means cyclic resonance is absent. Cyclic resonance is absent. But resonance is present. Correct? That is the difference between these two. Now, many students will ask me one doubt, sir, how to check whether cyclic resonance is present or not. So for most of the students, I will give you one shortcut that is very simple. Every single bond should be in alternate with either a double bond, or it should be a lone pair, or it should be a free electron, or it should be a positive charge, or it should be what? A negative charge. So you can think single bond, then it can be double bond or lone pair or free electron or positive charge or negative charge. Now next one should be what? Single bond. Then again what can be the possibility? Double bond or lone pair or single electron or positive charge or negative charge. Again single bond, again this will come, correct? So this will go in an alternate fashion. So if this is present throughout the ring, we say cyclic resonance is present. I hope you understood. If you want to know in detail, please contact Brainiacs Classes for detailed lectures. Now next comes the fourth condition, that is 4n plus 2 pi electrons. 4n plus 2 pi electrons. Now how to check this? Very simple, put n is equal to 0. Then what will happen? This becomes 2 pi electron. Put n is equal to 1. Then this will become 6 pi electron. Correct? You put n is equal to 2. Then this becomes 10 pi electron. And you can see here, every times it is increasing by 4. Correct? So this is an arithmetic progression. Now very simple, check the given compound and count the number of pi electrons. For example here, suppose the example given here is benzene, thing like that. So in this case, count the number of pi electrons. Here 2 electrons are there, here 2 electrons are there, here 2 electrons. So totally 6 pi electrons are there. Now check whether this 6 is coming in any of this list. So 6 is coming here. So I can say this will follow 4n plus 2 pi electron rule. Understood? Suppose the example is this one. Consider the example is this one. Okay. Count the number of pi electron. Here 2, here 2. So how many are there? 4 pi electrons are there. Now here check whether 4 is present. No. 2, 6, 10. Next it will be 14. Then it will be 18 and so on. There is no number like 4. That means this is not following Huckel's 4n plus 2 pi electron rule. So very simple, check all these 4 criteria. If 4 criteria are satisfied, then I can say Huckel's rule of aromaticity is followed. Okay. So come back to the question. Again, I am drawing the question for your understanding. So the question was this one, correct? Now tell me whether the given compound is aromatic or not. Let me check it one by one. Cyclic. Whether it is cyclic, because it is coming from here, then ending here, again coming here. So it keep on rotating like this, correct? So if you see here, this is cyclic in nature, correct? Now next one, we need to check whether it is planar or not. So to check the planarity, we will draw the structure in detail. Now I will come to this structure. So I know that carbon always have valency 4. So coming to this carbon, one valency is going like this, another valency going like this. And there is a positive charge is there. So what does this positive charge indicate? Positive charge comes when a bond breaks, correct? And the electron gets lost. So that means one valency is gone. So remaining how many valency is there? One more valency. That will be hydrogen. So if I am check the hybridization, I have taught you the shortcut. Put S here, then P here, then P. So this is what actually sp2. Correct? Now coming to this carbon atom. So here also one valency went in this way. One valency here, one valency here. So I know that 3 valencies are satisfied. So one will be what? Hydrogen. Now I will put S, then P, then whenever double bond comes, we will take it together. So together we are adding spp, that is sp2. Now similarly, it is similar to here. So hydrogen will come here. So this is also sp2. So that means the given compound is planar. Now comes the third condition. For third condition, let me draw the figure one more time. Figure is very, very important. So if you see here, third condition. So if you see here, you can see double bond, then single bond, then positive charge, then single bond, then double bond, single bond, positive charge. So it keeps on rotating in a periodic fashion. That means cyclic resonance is followed, correct? So I can put tick. Now last condition, check the number of pi electrons. So only 2 pi electrons are there. So when I check in the table 2, yes, 2 is present here. You can see here, correct? So I can say 4n plus 2 pi electron rule is followed. 4n plus 2 pi electron rule is followed. So all these 4 conditions are followed, means this compound is what actually? Aromatic. Understood? So this is how we will understand. Now we will go to the next question. Okay. Okay, come to the next question, 2Q, question number second. Now tell me whether this compound is aromatic or not. Okay, check it. So first condition, I will take another pen for your understanding. So it is starting here, then coming here, then coming here. So it is keep on rotating. So the condition of cyclic, it is followed. So cyclic. Now what is the next condition? Planarity. We will check actually. Now planar. Here also you can know that minus charge is there, means one bond is broken and a pair of electrons has come here. So let me draw it for checking the planarity. So you will get an idea. So coming to this carbon, you know one valency coming here, another valency going here, and one minus charge is there. That indicates one bond is broken. So one more valency is there, that is a hydrogen. So when I am distributing S, P, 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 you can distribute S, P, P in any fashion. It is not mandatory that S should come with the hydrogen. Okay, so add it S, P, P. So that is what actually sp2, correct? Now coming at this carbon atom, so one valency going here, another valency here, another valency here. So one should be what? Hydrogen. So I will put S here, this is P, and together when double bond comes, we will take it together. So this is what actually sp2. This is similar to this one, so this should also be what? sp2. So that means it is planar. Correct? Now next to check the cyclic resonance condition. I will draw the figure one more time. So cyclic resonance, how will you check it? Check it out. Double bond, single bond, minus charge, single bond, double bond, single bond, minus charge, single bond, double bond, single bond, negative. So cyclic resonance is present. Correct? Cyclic resonance is present. Now next comes the 4n plus 2 pi electron rule. Count the number of electrons that is entering into conjugation. So here there is 2 pi electrons are there, and there is a minus charge. That is also part of cyclic resonance. Minus charge is always 2 electrons. So totally how many 2 electrons are entering into resonance? I can say 4 pi electrons are there. And I know that 4 is a number that is not part of Huckel's rule. If you see here, you know that after 2 what is coming? 6 is coming, 4 is not there. So I can say that cyclic resonance is there, but it does not follow 4n plus 2 pi electron rule. This is not followed. So what is the answer then? The given compound, okay, it is not aromatic. Understood? So it is very one single change, plus charge changed to minus. That is the only difference in this question. So the question answer itself is changing. Understood? So we'll go to the next question. Okay, we will take different colors that will make this colorful. Okay, so we have the next question. I hope you could see. I am just drawing the question for you. Yeah, so here plus charge. Now check whether the given compound is aromatic or not. So there is a sincere request for all my repeaters and +1 and +2 students, those who the other YouTube watchers who liked our video, please subscribe the channel. And if you want any support for Neet exam, you can just contact Brainiacs Classes. Okay? Yeah, thank you. Now we will go into this question. First condition to check here is whether the compound is aromatic or cyclic or not. So first condition to be checked here is cyclic. So here it is coming here, it is joining here, it is joining here, it is joining here, it is joining here, again coming back to the initial position. So that means it is cyclic. Now next to check here is planarity. Correct? So planarity, what is the condition? We need to check the hybridization of the carbon. So let me draw the structure in a bigger way so that those students who didn't understand will also understand. Okay? Okay. Now let me take another color. Now if you see here, coming to the, I will take from here, this carbon atom. Okay? So if you see here, one valency of this carbon is going like this, another valency going like this, another valency going like this. So 3 valency is satisfied, but we know carbon is tetravalent. So where is the fourth valency? The fourth valency is hydrogen atom. Now let me put hybridization. So here I may say yes, this is P, and when double bond comes, we will take it together, then we will give P. So what is the hybridization here? sp2. Now we know this part is similar to left hand side. So I can say this is also what? sp2. Correct? Now coming to this part, again similar, one valency going here, one valency going here, another valency going here. So the fourth valency is a hydrogen atom. So if I put S, this is P, and together taking this one P, so this hybridization is sp2. If that is sp2, this should also be what? sp2. Now what about this one? We will see. So one valency going here, another valency going here, and plus charge indicates one bond has broken. Plus or minus charge indicates one bond has gone. Now there is only one more bond remaining, so that should be hydrogen atom. So I am putting S here, then P here, and P here. So if you are adding, this will also become what? sp2. So altogether every carbon atoms are sp2 hybridized. That means planarity condition is satisfied. Now let's check next condition, cyclic resonance. I will draw the structure one more time. So if you have plus charge here, and there is double bond here and double bond here. Now check double bond, single bond, double bond, single bond, positive charge, single bond, double bond, single bond, double bond, single bond, positive charge. So it keeps on rotating in throughout the cyclic structure. So I can say cyclic resonance is present. Cyclic resonance is present. Next, count the number of pi electrons. I know 2 pi electrons are present in this bond. Another 2 pi electrons are present in this bond. There is no other charges and electrons entering into resonance. So totally 4 pi electrons are there. And I know 4 is not a part of Huckel's 4n+2 rule. So that means this is not followed. That means the compound is not aromatic. It is not aromatic. Understood? So I hope students it is becoming clear for you. Now let's go to the next question. We will take a new color. Okay. Okay, question number 4. So there is only one difference I am making for this question. You can try yourself. Okay, this looks like a house. Correct? Yeah, only one difference. I am making it as negative charge. Now tell me whether the compound is cyclic. Yes, you know it is cyclic. Correct? We have already learnt. Now next to check whether it is planar. I know already I checked this condition in the last question. This one also I know it is sp2. This is sp2. Correct? And this is sp2. And this is sp2. And I need to check only here. One valency went here, one valency went here. And you know minus charge. So minus charge comes means a bond is broken and a pair of electrons come to this carbon atom. And what happens to the third valency? Yeah, that is hydrogen atom. So totally spp. So this should also be what? sp2. So the compound is planar. Next, what you need to check? Cyclic resonance. Correct? So cyclic resonance, just check it out. You know that there is double bond, then single bond, then double bond, then single bond, then negative charge, then single bond, then double bond, then single bond, double bond, single bond, negative charge. So it keeps on conjugating. Conjugating means alternating in nature. So cyclic resonance is present. Now count the number of pi electrons entering into resonance. Here 2 pi electrons are coming. Here also 2 pi electrons are coming, and a negative charge is also coming. So negative charge means 2 electrons, 2 pi electrons. So totally 6 pi electrons are part of it. Now let's see, 6 is part of this one. So coming back to here, I know that 6, yes, 6 is a part of Huckel's rule. When n is equal to 1, 6 will come. Correct? So when n is equal to 1, 6 will come. So that means Huckel's rule, Huckel's 4n+2 pi electron rule is also followed. So the compound is what? Actually aromatic. Understood? Very simple, right? Yeah. Next we will go to the next question. I will give you a little more tough questions. Next question. Okay, I will draw the structure. So now tell me whether the given compound, I will draw this one. This we have already seen. Okay, tell me this famous compound. Everybody knows. Okay, but apply the rule. This is benzene, and you know it is aromatic, and I also know that. Just apply the rule and ensure that it is following or not. So the first condition of cyclicity, cyclic, is followed. You know that it is cyclic in nature. Now next to check what sp2 hybridization. Now I know that when I come to here, one valence event here, another valence event here, another valence. So this should be hydrogen atom. So yes, this is P and this is P. This I am taking together. So sp2. I know that all other carbon atoms are similar in nature. So this is planar or sp2 hybridized. Now what is the next condition? Next condition is cyclic resonance. Double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond. So you know that this is following cyclic resonance. Correct? So this condition is followed, this condition is followed. Now last condition, count the number of pi electrons. 2, 4, 6. So totally 6 pi electrons are there. I know 6 is a number that is part of Huckel's 4n plus 2 pi electron rule. When n is equal to 1, that will be 4n plus 2. So this will become 4 plus 2, 6. So that means it is following Huckel's rule. So that means the compound is aromatic. Understood? So this is how we check. Now we will go to the next question. Question number 6. Okay. So coming to the question number 6. Let me draw the question. Now tell me whether this compound is aromatic or not. Check whether this question, the given question, is aromatic or not. Okay, very simple. I can check the first condition, cyclicity is followed. Correct? It is cyclic. Now the next condition is planarity. I know this is, if I see 2 valency comes here, 1 valency comes here, so third one should be hydrogen, fourth one should be hydrogen atom. So that means this is, I am taking together spp. So this is sp2 and this is also sp2. You can check it out. This is also sp2 and this is also sp2. But what about this one? If I look here, one valence event here, another valence event here. So remaining 2 valency, this should be hydrogen and this should be hydrogen. So when I am distributing, this is S, this is P, this is P, this is P. So this becomes what? sp3. So that means it is not planar. There is sp3. sp3 means it is tetrahedral. So from this itself, I will understand this is not aromatic. I don't want to check the other conditions. If one of the condition is not followed, I can say it is not aromatic. Correct? Maybe you can check the other conditions and also ensure. Okay, that is for your practice. Now we will go to the next question. Question number 7. Okay. Let's see the question number 7. This is another wonderful question for you. Okay. Let's see how many of you answer this question. Now tell me whether the given compound is aromatic or not. So the first condition, cyclicity. Yeah, it is starting here. Here it is cyclic in nature. So cyclic. Now what is the next condition? Planar. So let me look at this one. One valency is going here, 2 valency going here. So this one should be hydrogen atom. So this is S, this is P, together I am taking, so this is P. So this should be sp2. If that is sp2, this is also sp2. Correct? So here minus charge comes means a bond is broken. So let me say one valence event here, one valence event here. So third valence is hydrogen atom. So yes, here P, here P. That means this is also sp2. If that is sp2, this is also sp2. So that means it is planar. Correct? Now let me draw the structure one more time, then only you will get a clear idea. Okay. So if you see here, check whether cyclic resonance is present. Double bond, single bond, minus charge, single bond, minus charge, single bond, double bond, single bond, minus charge, single bond, minus charge, single bond, double bond. So you can see single bond is in conjugation or alternating with either double bond or negative charge. So that means cyclic resonance is present. Now next we will count the number of pi electrons entering into resonance. So here 2 pi electrons are coming. Here negative charge means 2 pi electrons coming into resonance. Here 2 electrons coming into resonance. So totally 6 pi electrons. I know that 6 is a number which follow Huckel's 4n plus 2 rule. So all 4 conditions are satisfied. So the given compound is what? Actually, it is aromatic in nature. I hope it is clear for you. Now we will do the next question. Okay. So what is the question number? Question number 8. So coming to the 8th question. I hope now you got a fair idea. Okay. So let's see whether you are able to do this question or not. I'm drawing the question for you. So I hope you will do it. Okay. This is a good question. It's a repeated question also. Let's see how my students handle. Whether it was right. Yeah, somehow. Okay, it can be made more beautiful. 1 minute. Let me try it out. Okay. So, okay. Yeah. Now let me say here positive charge is present. Then you have double bond here. And a double bond is present here and another double bond is present. Now tell me whether this compound is aromatic or not. Again, you know that cyclic. Yes, the compound is cyclic in nature. Correct? It's starting from here. You have another carbon atom, 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 another. So it is rotating in it. So it's cyclic. Next condition is planarity. Correct? So check for the hybridization. So very simple. I will tell you another shortcut. If you have a double bond in a carbon and the other two valencies are like this, this will be always spp. So this should be what? sp2. So I know that this will be sp2. Correct? And this will be sp2 because the same condition. This will be sp2. And always my students will ask, sir, here 2, 3 valencies are there. What happened to the fourth valency? What should be the fourth valency? It should be hydrogen atom. Okay. So this is also sp2, this is sp2, and this is sp2. And what about this one? That is another shortcut. So sometimes if you have something like this, one valency here, one valency here, the third valency is a hydrogen atom. Plus or minus indicates one bond is broken. So this should be S, this should be P, this should be P. This would be always sp2. So this is also sp2. So that means the compound is planar. Next we will check for the cyclic resonance. We know that positive charge, single bond, double bond, single bond, double bond, single bond, double bond, single bond, positive charge. So you could see cyclic resonance also present. Cyclic resonance. Correct? Cyclic resonance. Next we count the number of pi electrons. 2 present here, 2 present here, another 2 present. So totally 6 pi electrons. So 6 pi electrons means it is a part of Huckel's rule. So the compound is what actually? Aromatic. Understood? Okay. Now let's start doing the next question. Coming to the 9th question for you. Tell me the given compound is aromatic or not. Now I am going to the next set of questions. That is very important. Okay. Yeah. These are important questions. Can you tell me whether the given compound is aromatic or not? So very important condition to be checked here is, I know that again it's all cyclic in nature. So cyclicity is followed. Correct? Next condition is planarity. Okay. Check the carbon atom. This is sp2. Correct? You know it now. This is also sp2. This is also sp2. And what about this one? This will also be sp2. And here you have oxygen atom. Please remember, whenever electronegative atoms like oxygen, sulfur, then what and all you can say, nitrogen, all these people are there. Always consider the lone pairs. Oxygen has 2 lone pairs. Okay. And now the important question here is whether the two lone pairs will enter into resonance. No, because for conjugation there is double bond, single bond, double bond, single bond. There should be one lone pair should only be entering, and please count only that lone pair for the 4n plus 2 pi electron rule. Okay, now and don't consider the hybridization of oxygen also, consider only the hybridization of carbon atom. So I understood this is planar, correct? Now cyclic resonance, yes, the single bond, double single bond, double bond, single bond, double bond, single bond, then lone pair. Any of the lone pair will come, but not the two lone pairs. Okay, so cyclic resonance is also followed. But please remember, for an exam they will not show the lone pair in oxygen atom. That you should understand or you should remember, because oxygen is an electronegative atom, so it will have two lone pairs mainly. Next condition, 4n plus 2 rule. So 2 pi electrons here, correct? So another 2 pi electrons here, and out of this oxygen's 4 pi electrons, 2 will enter into resonance. We will only count the number of pi electrons that is entering into resonance. So totally 6 pi electrons. So that is also followed. So the compound is what actually? Aromatic. Understood? So this is another important question. Now we will do the next question. Question number 10. Okay. So comment whether this compound is aromatic or not. Yeah. Do it. So here also you have a cyclic ring is very much visible. As part of the cyclic ring, nitrogen is also part of the cyclic ring. So this type of rings are called heterocyclic. You might be knowing it. So it is cyclic. That is very clear. Now what is the next condition? Now we can check planarity. We know this, we have already learned. One valency going here, one valency here, one valency here, three valencies. So the other one should be hydrogen atom. So yes, this is P. Double bond comes, we will take together. So P, this should be sp2. If this is sp2, this is also sp2, this is also sp2, and this is also sp2. So it is planar, correct? Now next we will check what actually cyclic resonance. I will draw the structure one more time. Correct? So let's see. So here double bond, single bond, double bond, single bond. We know nitrogen has a lone pair. Then only the valency will be satisfied. 2, 4, 6. This lone pair is 8. So double bond, single bond, double bond, single bond. Then comes lone pair, then single bond, double bond. So cyclic resonance is present. Now count the number of pi electrons. 2 here, correct? From here 2. From here 2, then lone pair from nitrogen. So totally 6 pi electrons. So this compound is what actually? Aromatic. Understood? So I hope you got a fair idea regarding the aromaticity topic. Hi dear students. So in our last class we were learning about aromaticity. We have seen many problems, and we hope you remember we discussed the 4 criteria also. Okay, so the next important topic that I am going to discuss in the first part of this chapter is classification of carbon and hydrogen. Okay, so you will think, okay sir, how to classify carbon and hydrogen? Yes, it is possible. So I can say carbon atom is classified into, I can say, listen here, carbon atom is classified into 1 degree carbon atom. 1 degree carbon atom. It is also known by the name primary carbon atom. What is it? Primary carbon atom. And the other classification, it is further divided into, it can be 2 degree carbon atom. 2 degree carbon atom. So 2 degree is also called secondary carbon atom. Okay, and it is also classified into another one that is called 3 degree carbon atom. 3 degree carbon atom, and it is also called tertiary carbon atom. And one more is there, that is called, the fourth one, that is called 4-degree carbon atom. Can you name what it is called actually? Other than 4-degree, we can say this as quaternary carbon atom. Understood? So basically carbon atom, it is classified into 1-degree, 2-degree, 3-degree and 4-degree carbon atom. Now you need to know what do you mean by a primary carbon atom. Please listen here. I will explain. Suppose think like this is your carbon atom. I am drawing a compound CH3, CH3. What is this compound? This is called ethane, correct? C2H6. Now, if I look into this carbon atom, if you see here, this carbon atom, its 3 valency is satisfied by hydrogen atom and 1 valency is connected to another carbon atom. So that means this carbon atom is only connected to one other carbon atom. Those carbon atoms are called 1-degree carbon atom. If the carbon atom is connected to only one another carbon, then we say such carbon atoms are called primary carbon atoms. Understood? And if you see here, what about this carbon atom? This is also connected to 3 other hydrogen atoms and the 4th valency it is connected to this carbon atom. So this is also what sort of carbon atom? This is also a primary carbon atom. Understood? Now let's see what is basically a secondary carbon atom. Okay, so let's see what is basically a secondary carbon atom. So let me rub this. So I will rub now so that it becomes easy for me to explain. Now let's see what is a secondary carbon atom. I can give you the example something like this. CH3, okay, CH3, okay, CH3, CH2, CH3. Suppose this is the example given. Now how I will identify the carbon atom? Listen here. So I can see this carbon atom, the 3 valency, I know that one is hydrogen, another one was hydrogen and the next one was also hydrogen. So 3 valency was hydrogen and only 1 valency is connected to another carbon atom. So this should be what actually it is a 1-degree carbon atom. Correct? Now if I see it this one, you can see this one also similar, right? Because here also one is hydrogen, 3 hydrogens are there. So 3 valency is connected to hydrogen and the 4th valency is connected to carbon. So that means it is also connected to one other carbon atom. So this is also what sort of carbon? 1-degree carbon. Correct? Now let's look at this one. Now if I look at this one, you can see here one is hydrogen, it is connected to another, 2 hydrogens are connected. And if you see the 3rd valency, it is connected to another carbon, this is also connected to carbon, 4th valency. That means this carbon atom is connected to 2 other carbon atoms. So what sort of carbon is this one? This is a 2-degree carbon. Understood? So this is how we should understand this. Now let's see another example for a 3-degree carbon. Let me draw it. Okay. So let's see how a 3-degree carbon looks like. Now CH3, CH, CH3, CH3. Suppose this is the example given. Now tell me, I will focus on the first one. This is connected to only one other carbon atom. So this is 1-degree carbon. I will look at this one. This is connected to one only carbon atom. So this is also 1-degree carbon atom. And if I look at this carbon atom, this is connected to one only carbon atom. So this is also 1-degree carbon atom. Correct? Now if I am looking at this one, this carbon atom, this is connected to one carbon atom here. This is connected to another carbon atom here. And this is connected to 3rd carbon atom here. So it is connected to 3 other carbon atoms. So this should be what actually? This should be a 3-degree carbon. Understood? So this is how we will identify 3-degree carbon. 3-degree carbon is also called what? Tertiary carbon atom. Correct? Now let's see an example for understanding a 4-degree carbon atom. Okay? So let's see how a 4-degree carbon atom looks like. Okay, I will draw you one example for that. So let's see CH3, CCH3, CCH3 and CH3. Now in this example, now you will be able to identify it very easily. Now tell me, this carbon atom connected to only one other carbon atom. So this is a 1 degree carbon. And what about this carbon atom? This is also connected to one other carbon atom. So this is also a 1 degree carbon. Now what about this one? This is also connected to one other carbon atom. So this is also 1 degree carbon. And what about this one? This is also connected to one other carbon. So this is also a 1 degree carbon. Correct? Now we focus on the central carbon atom. This is connected to one carbon atom. Its another valency is connected to other carbon atom. Its third valency is also connected to other carbon atom, and fourth valency is also connected to other carbon atom. That means it is connected to 4 other carbon atoms. So this should be what sort of carbon it is? It is called 4 degree carbon, or it is also called quaternary carbon atom. Clear? So I hope the definitions are very much clear for you. In a 1 degree carbon, the carbon atom will be connected to only one other carbon atom near to it. In a 2 degree carbon, the carbon atom, what we are telling, will be connected to 2 other carbon atoms adjacent to it. And in a 3 degree carbon, the carbon atom will be connected to 3 other nearby carbon atoms. And in a 4 degree carbon, this will be connected to 4 other nearby carbon atoms. Clear for you? Now let's see what is the classification of hydrogen. Okay, so until now we have seen the classification of carbon. Now let's see the classification of hydrogen. So I can say hydrogen, classification of hydrogen, classification of hydrogen. So hydrogen also classified into 1 degree hydrogen. 1 degree hydrogen, it is also called primary hydrogen. It is also called primary hydrogen, and it is also classified into 2 degree hydrogen. 2 degree hydrogen, it is also called secondary hydrogen. Okay, and thirdly, it is classified into 3 degree hydrogen. 3 degree hydrogen, or it is called tertiary hydrogen. Tertiary hydrogen. And I hope all of you are expecting for a 4 degree hydrogen. There is no 4 degree hydrogen. I will explain the reason. Please remember, only 1 degree hydrogen atom and 2 degree hydrogen atom and 3 degree hydrogen atom is only there. I will tell why it is. 1 degree hydrogen atom is that hydrogen atom which is connected to a 1 degree carbon atom. I will tell one more time. 1 degree hydrogen atom is that hydrogen which is connected to a 1 degree carbon atom. Similarly, a 2 degree hydrogen is those hydrogens which are connected to a 2 degree carbon atom. And similarly, a 3 degree hydrogen is that hydrogen which is connected to a 3 degree tertiary carbon atom. Now you can ask, sir, in that case then 4 degree hydrogen is that hydrogen which is connected to a 4 degree carbon atom. But you know that a 4 degree carbon atom has all the 4 valencies connected to other 4 carbon atoms. Then there is no space. There is no more valencies available. In that case, whether hydrogen will be there in a 4 degree carbon atom? No. That is the reason why there is no 4 degree hydrogen available. Now let's see some questions and understand this in a much more better way. Okay. So let's see. I will write down a question and you need to tell me how many primary hydrogen atom, secondary hydrogen atom, secondary carbon atoms, everything are there. Okay. Let me write down the example. CH3, CH, CH3, CH, CH3, C, CH3, okay, CH3 and CH3. This is the question. Now you need to tell me, I will number this carbon atom. It is not the nomenclature. I am not telling about any nomenclature. It is the usual simple numbering I am doing. Or I will put the A, B, C, D. This is A, this is B, this is C, this is D, this is E, this is F, this is G, this is H, this is I. Now you need to tell for A what sort of carbon it is. Then I will hope you have understood this. Okay. Now if I see here, you can remember like this carbon atom, it is connected to only one other carbon atom and the remaining 3 are connected to hydrogen. So I know that A is a what sort of carbon? Primary carbon. Correct? A is a primary carbon. Now tell me, if A is this carbon atom is a primary carbon, means the hydrogen atom attached to a primary carbon is called what sort of hydrogen? Primary hydrogen. Now tell me, how many primary hydrogen is associated with the carbon A? I know that 3 hydrogen atom is attached. So 3 primary hydrogens are there. So I can say here 3 primary hydrogen is attached to A. Correct? Now let's see what about B. Can you tell me what sort of carbon it is? If you see here, the carbon atom is connected to here one carbon atom, it is connected to another carbon atom, it is connected to another carbon atom. So I can say this is a 3 degree carbon. Correct? So this one was a 1 degree carbon and this is a 3 degree carbon. So the hydrogen attached to a 3 degree carbon is called 3 degree hydrogen. So tell me, what is this then? This is a, so this is a, I can say this is a 3 degree hydrogen. Correct? Now look at the example, look at the carbon number C. Now tell me what sort of carbon it is. If I see here, this carbon atom is connected to only this carbon atom. Correct? So this is again what actually, it is a 1 degree carbon. And I know that hydrogen attached to 1 degree carbon is called primary hydrogen. So the 3 here, what and all hydrogen you are seeing here is what sort of hydrogen is that? 1 degree hydrogen. Correct? Now let's see D. Coming to D. If you see here, this carbon atom is connected to here, it is connected to here, it is connected to here. So again, this is a what sort of carbon? 3 degree carbon. If that is a 3 degree carbon, the hydrogen which is attached to this one, this should be what actually? It should be a 3 degree hydrogen. Understood? Now coming to E. Tell me, I hope now it is very much clear for you. This carbon atom is connected to only this carbon atom. So this is again a 1 degree carbon. Correct? And what about the hydrogen? You can see there that hydrogen which is connected to 1 degree carbon is 1 degree hydrogen. So these 3 hydrogen atoms are what actually? 1 degree hydrogen atoms. Correct? Now can you come to next one? We completed up to E, then we are going to F. This carbon atom is connected to this one, this one, this one, this one. That means all the 4 carbon atoms, it is connected to all 4 other carbon atoms. So this should be what actually? It is a 4 degree carbon. And you know that in 4 degree carbon, all the 4 valencies are carbon atoms. So there is no space for what? Hydrogen atom, because the valency of carbon maximum is 4. Correct? Now this is 4 degree carbon. So if it is 4 degree carbon, there will be no hydrogen associated with it. Now coming to EFG, this is connected to only one other carbon atom. So this is also 1 degree carbon. Then the corresponding hydrogen should be what actually? It should be 1 degree hydrogen atom. Correct? Now coming to H, tell me. So H, if you see this carbon atom, this is connected to only one other carbon atom. So this should be a 1 degree carbon. Then the hydrogen attached to that, this one, correct? This should be 1 degree hydrogen. Now what about this one? I, you can see carbon atom is connected to only one other carbon atom. So this should be 1 degree carbon atom. Then I can say the hydrogen attached to that, this should be what actually? 1 degree hydrogen. Now in exam, they will not give you questions like this. They will just ask you to give the structure and ask you to count the number of primary hydrogen atom. How will you count? I know that here, how many are there? So this is also 1 degree hydrogen. Now if you count here, this is 1 degree. So 3 here, another 3 plus 3, 6 here, another 3, so 9 here, then another 3, then 12 here, another 3, 12 plus 3 15 here, another 3, 15 plus 3 18. So I can say totally 18 1 degree hydrogen atoms are there. So how many primary carbon atoms are there? 1 2 3 4 5 6. So 6 primary carbon atoms are there. And what about how many second degree carbon atoms are there? There is no second degree carbon atom. If there is no second degree carbon atom, there is no second degree hydrogen atom is also not present. Now what about how many 3 degree carbon atoms? Here you can see 1 and 2. So totally 2 3 degree carbon atoms are present. So how many 3 degree hydrogens are there? You can see 1 here, another 1 here. So totally 2. And how many quaternary carbon atoms are there? Only 1 quaternary carbon atom, and there is no concept of quaternary hydrogen atom. So I hope you understood the classification of carbon and hydrogen as primary, secondary, tertiary, quaternary, and hydrogen atom as primary, secondary, and tertiary. Okay, thank you. Now let's go to the next topic. Next we are going to discuss the last section of the first part. Then thereafter we will go to isomerism. Okay, that is the hybridization of carbon atom. But already we have seen this hybridization in aromaticity little bit. Here I will give you a clear picture what it is. Okay, so the phenomenon of hybridization will be explained in the chapter chemical bonding, but here I will give you a fair idea what is basically hybridization. So let me say I will talk with respect to carbon, because carbon forms the fundamental of organic chemistry. Listen, so I know that you have carbon. What is its atomic number? So carbon, the atomic number is, if you see, the atomic number of carbon is 6, correct? So 6 means what is its electronic configuration? So I can say the electronic configuration of carbon is 1s2, 2s2 and 2p2, correct? Since its atomic number is 6, that means it has 6 electrons, so its electronic configuration is 1s2, 2s2 and 2p2. Now we know that S means it is an orbital, so there is only one S orbital that is spherical in nature, correct? And you can see also here p orbital is also present for carbon atom. So p orbital can be of different shapes. It can be, as you know, 1 minute. So this can be, if I say it is in the x direction, then I can say this can be px, correct? Or it can be, if it is in the y, I can say this can be py, or it can be even, if you see this is projecting from the board, if it is z, then I can say this can be pz, correct? So these are the 3 orbitals for p, it is possible. So I know it is 6 is the electrons. Now the question here is where these electrons are entering into. So what will happen here is these s and p orbitals can undergo mixing. So the mixing of s and p orbitals to form degenerate orbitals. Degenerate means orbitals having same energy. So mixing of the these orbitals, s and p orbitals, valence orbitals, especially valence orbitals will only enter in hybridization. The mixing of the s and p orbitals or valence s and p orbitals to form orbitals of equal energy, that phenomenon is called hybridization. Now as I know, if you look into the valence shell of the carbon atom, if you see the valence shell of the carbon atom, you can see what and all orbitals are present here. Since 2 is the last number, I can see the valence shell is these 2. So what are the valence shell, possible shells available? S and P, correct? Now we need to see with S and P what are the possible types of mixings possible. So as per hybridization, we know that S and P can be Sp, or it can be Sp2, or it can be Sp3. This is the maximum mixing possible. So I can say that carbon atom can have these three possible hybridization. One is Sp, another Sp2 and another is Sp3. Understood? Now if we look at this one, if you try to see this in blocks, I know that this is 1s2, correct? And if you see this one, you can see this is 2s2, and p, you know that 3 orbitals are there, px, py and pz. Now if I see like this, px and this is py, this is 2px and 2py, and you have 2pz vacant. Now during hybridization it can mix, or these electrons can mix in different ways. As I told, it can be sp, sp2 or sp3. If it is sp hybridization, what will happen here is this electron will come and join here, so that these two orbitals mix together and form what actually? Sp. Understood? Now suppose if it is sp3 hybridization, what will happen? You already have two electrons here. One more electron from the last orbital, from the s orbital, will excite and come over here. So you have how many orbitals there? S, p, p, p. So totally I can say this will form what actually? sp3 hybridization. Understood? So likewise it is possible that it can form, suppose if it is not the other way, suppose if it is maintaining like this, then spp, then it is sp2 hybridization. So basically based on this I can say the carbon can form three possible hybridizations, that is sp, sp2 and sp3. Now I will give you a simple idea to identify the hybridization in carbon atom. Listen here. Okay, so this is 1s2, 2s2, 2p2. So basic simple technique is, if you see here, what are the basic type of bondings possible for carbon? Carbon can form completely single bond, carbon can form double bonds, and carbon can form triple bonds. And if the carbon is forming only single bonds, something like this, then I can say this hybridization is sp3. Understood? So for students, what I will tell a shortcut is, what you need to do, suppose if you are not remembering, what you do is put here s, then p, then p, then p, then count it, s and 3p is there, so it is sp3. This is the simplest technique I used to tell to students. And suppose the carbon forms double bond, something like this, you can see here. Here also all the times the valency of the carbon is what actually? You can see what is the number of valence electrons? 4. So here also one electron, one electron, one electron, one electron, and the other electron comes from the bonding pair, correct? Whoever comes here, hydrogen atom means one electron from the hydrogen atom. Now here also if you see one electron here, one electron, one electron, one electron, so totally 4 electrons, and the other one will come from the with whom it is forming the bonding, from there other electron will come. Now if this is the case, the hybridization is sp2. So for students to remember, I will tell a shortcut, very simple. What you need to do, take this double bond, whenever double bond or triple bond comes, you take it together, and you can assign anything, it is okay, fine. If you give s here, then p, then add it, it will become sp2. Understood? Now coming to the third possibility, it can also form triple bond. So the triple bond will be like this. So here also if you see 1, 2, 3, 4, again 4 valence electrons are there. Now in this case, what will be the hybridization? The hybridization here is sp. Okay, so in this case, easiest way as I told is, if double bond comes, take it together, then put s and this is p, so add it, it will become sp. This is the simplest way to do it. And in addition to that, there is a fourth possibility. I will explain that also. This is the fourth possibility. Suppose if it is like this, 2 double bonds, again 1, 2, 3, valency 4 is satisfied, correct? So what will be the hybridization? Here also our rule remains the same, take it together, this also take it together. So this is S, this is P. So what is the hybridization? SP. Understood? So for SP hybridization, 2 possibilities are there, and there is SP3 and SP2. I hope you understood. Now let's try to see some questions and identify the hybridization of the carbon atom. Okay, it's a very important question that used to come for Neet. It comes under EC category. Let's see how it is. Now, Okay, I hope you are understanding the lectures, and if you have any doubt, please feel free to ask. Unless you don't ask, we will not understand. We all think like you have understood all the lectures and you are doing fine. Okay, if you are not understanding, please let me know in the doubt clearance group. So let me give you a question. Okay, CH3, CH2, CH double bond CH2 and C triple bond CH. Okay, now let me say this carbon atom as my A, this carbon atom is B, this carbon atom is C, this is D, this is E, and this is F. Now can you comment on the hybridization of the carbon atom A, B, C, D, E and F? Like this they will ask in the question. Okay, so let's see if the first one CH3 here. What I will do is, for these questions, is easiest way to remember here is expand the diagram, then it becomes easy. I am going for A. So CH3 is there, means H is present here, H is present here, H is present here. Correct? Now you put the sp3. This is S, this is P, this is P, this is P. So tell me what is the hybridization of this carbon atom? sp3. Very easy. This is the easiest way to do it. Now rub this. Now we will move to the next one. Okay, in the next one what you need to do, again expand it. 2 hydrogen atoms are there, so put it here, hydrogen, hydrogen. Now again do the same thing. Start from the left. Yes, P, P, P. So again add it. This is also what? sp3. Once you have done it, rub it. Okay, this is to avoid confusion. Now we again go to C. Now I have come to C. Again for C I am doing, this is S, this is P, double bond comes, I will take it together. So this is P. So what is the hybridization? The hybridization is sp2. Understood? Now come to the F. Here also 2 hydrogen atoms, so let me expand hydrogen, this is hydrogen. Now again I will distribute here. Already P is here, then I will put S, this is P and this is P. So add it, this will become sp2. Correct? Now come to the next one, this carbon atom D. So let me see here. Here only one here is, so I will put here S. I will put S and triple bond is there, so I will take it as 1 S and P. So this is sp. And come to the last one, E. Here also I expand the hydrogen. Okay, now you take it. So this I will take together and put P, and this is S. Then this should also be what? sp. So this is how usually we identify the hybridization of the carbon atom for questions. So this becomes very easy whenever you do for the exams. And there is a special case is there. Let me tell that also. Otherwise some students will ask me later, not now. Okay, I hope this is clear for you. Let me explain the special case. Okay, the special case is where the carbon atom will have some lone pair. For example, hydrogen atom present like this. 3 hydrogen atom and a lone pair is present. Okay, so if lone pair is present, there are 2 possibilities are there. Let me tell, that is what is very important actually. So if a lone pair is present, the first possibility you need to consider here is, if lone pair is available for bond formation. If lone pair is available for bond formation. If lone pair is available for bond formation, then consider the same electrons entering into hybrid orbitals. Very, very important. So this we cannot tell from the diagram. So let us assume in this case this lone pair is available for bond formation with some other electron deficient gas. That means this electron will enter into hybridized orbitals. Then we need to take this also for hybridization. That means put here S, this is P, and this lone pair should also be given entering into some hybrid orbitals as P, and we can say the hybridization here is what? sp3. Okay, this is the first case. And the second case, please listen here. I will explain that with another example so that you will understand. So the second case here is I hope you could see here the diagram, and lone pair is here. Now in this case, I can say this lone pair, I am explaining with respect to carbon, so I will take carbon only so that it will be easy for you to understand. So the same thing, only difference is I am going to make this as a carbon. Okay. Suppose for carbon, if there is a pair of electrons available, earlier we have seen we need to consider that for hybridization. But this is a special case. Here what is happening? You know that double bond is present, single bond, double bond, single bond, then comes lone pair, then single bond. So that means there is a cyclic resonance is present. That means in the second case, if cyclic resonance is present, if cyclic or resonance or normal resonance, let it be like that. If cyclic resonance or resonance is present, what will happen? This lone pair will not be available for what? Bond formation, or I can say this lone pair will not enter into the hybrid orbitals. Why? Because these keep on switching like this. How this will form a bond here, then this will become lone pair here, this will become a negative charge here, then that will switch into a double bond here. That means it keep on delocalizing. I have told, right, resonance is what? Actually delocalization of pi electrons. That means that pi electrons is not available for bond formation or not going into any hybrid orbitals. Then if cyclic resonance is present or resonance is present, do not consider those pi electrons for hybridization. Very, very important. So that is the reason why if I look at the hybridization of this carbon, I will take this as S, okay, this as P and this also as P, but I will not consider this electrons. Why? Because this will enter into cyclic resonance. So my hybridization here is sp2. Understood? So many students will have a doubt like this. So first, if they are learning the initial thing, they will say, sir, why don't you consider lone pair for hybridization? The reason here is this lone pair is entering into resonance. If lone pair is available for resonance, means it will keep on delocalizing, moving. Then how it can form a hybrid orbital? Not possible. If it is not able to form a hybrid orbital, then we cannot consider that for what? Hybridization. Very simple. That is the reason. If cyclic resonance or resonance is present, do not consider those pi electrons for hybridization. So I hope you got a fair idea regarding the hybridization. And one more thing I need to tell, that is the shapes with respect to each bonds. That is also very important. That will help you in understanding. Anyway, you will learn the same thing in chemical bonding, but let me tell. So suppose if you have this as the possible valency, that is 4 different valencies are available. You know that how many, all these bond will be what sort of bond? Sigma bond. If it is a single bond, it will be always sigma bond. So I can say it has 4 sigma bond and 0 pi bond. Now what is the hybridization of this one? As we have learned, this is sp3. If sp3 is the hybridization, the shape is tetrahedral. Clear? Tetrahedral. Okay. Now the next possibility like this. So in this case there is this one sigma, this is a sigma, this is a sigma, and this is a pi bond. So I can say there is 3 sigma bond and 1 pi bond. So what is the hybridization here? sp2. If sp2 is the hybridization, what is the shape? I can say trigonal planar. Trigonal planar. Either you can say trigonal planar or planar. Okay. Now comes the next one. Suppose if it is like this. Now tell me how many sigma bond? This is a sigma bond. Okay, this is a pi bond. This is a pi bond, and this is another sigma bond. So I can say there is 2 sigma and 2 pi bonds. And what is the hybridization here? It is sp hybridization. So sp hybridization means the shape is linear. And the last possibility, as you all know, I will take a special color for that. Suppose if it is like this. Okay, so I know this is a sigma, this is a pi, this is a sigma, this is a pi. So there is 2 sigma and 2 pi, and this is also sp. If sp is the hybridization, then it is linear. Okay. So I hope with this you are now thorough with what is called hybridization of carbon atom and the different possible hybridizations. Clear? Thank you.